Hi, welcome to my channel pibyme Maths. This is by WST02. Here we are solving October-November 2021 Statistics 2 paper. In the previous video, we have completed question number 1, 2 and 3. Let's look at question number 4. The number of cars entering a safari park per 10-minute period can be modeled using a Pearson distribution with mean 6. Okay, 6 per minute. Find the probability that in a given 10-minute period, so they are using the same 10 minutes, so you can take this as lambda. So you can write x follows Pearson distribution of 6. They want you to find the probability exactly 8 cars will enter. So P of x is equal to 8 is e power minus lambda, lambda power x over x factorial. So e to the power minus lambda times lambda to the power x over x factorial. 0.10325 dot dot dot, round it to 3 significant figures, 0.103. That's all, just a 2 mark question. Let's look at part B now. Find the smallest value of n such that probability that at least n cars enter the safari park in 10 minutes, so we still use x follows Pearson distribution of 6. It says x is at least n cars, so greater than or equal to n is equal to 0.05. You can rewrite this as 1 minus p of x is less than n or less than or equal to n minus 1 is 0.05. Rearrange the equation, you will get x is less than or equal to n minus 1 is 1 minus this 0.95. But the question says find the smallest value of n such that, okay, no problem, let's get this value now. So we need to find the probability of, look at the table value for lambda is equal to 6 and take all the values of x that satisfies this condition, 0.95 or more, and then we will take the smallest value of n. Okay, here is the lambda value. Okay, here is lambda is equal to 6, the second column. We need to look at the values that are bigger than 0.95. That's 10, 11, all these values. So the smallest value is 10, right? So you need to write n minus 1 is equal to 10, n is equal to 11. That's all. Part C now. Find the probability that no cars enter the safari park in 10 m minutes. Okay, we know it's the mean rate is 6 per minute. 6 per minute. So for m minutes, it's gonna be 6 per 10 minutes. That's what given here, right? 6 per 10 minutes. So for m minutes, it's gonna be 6 over 10 times m. That's going to be the new lambda, 0.6 m. So we can define a distribution y follows Pearson distribution of 0.6 m. The question says no cars enter, y is 0. Okay, the probability is less than this. So how do you write the formula? E power minus lambda. Lambda power 0 by 0 factorial is 1. Just leave it. Take natural logarithm both sides. The e will be gone. You will get natural logarithm of 0.05. So m is greater than natural logarithm of 0.05 divided by minus 0.6. So natural logarithm of 0.05 divided by minus 0.6. 4.999 dot dot. Therefore m is equal to 5. Part D now. A car enters the safari park. Okay, the car enters at this point. Okay, find the probability that there is less than 5 minutes before the next car enters. Okay, this is the 5-minute interval. So they are saying in this less than 5 minutes, the next car enters. So at least one car enters before the 5 minutes, right? We know the mean rate is 6 per 10 minutes. So for 5 minutes, it's going to be 6 over 10 times 5 is 3, right? So lambda is, the new lambda is 3. So I'm going to define a probability distribution, Poisson distribution of 3 now. It says at least 1. So C is greater than or equal to 1. They want you to find this probability, which is 1 minus C, or C is less than 1 or less than 1 is 0, which is 1 minus, find the probability of 0 here for lambda is equal to 3. For lambda is equal to 3, it's 0.0498. 0.0498, so it's going to be 0.9502. That's all. Now the 3-mark question. Part E. Given that exactly 15 cars entered in the safari park in a 30-minute period. Okay. The mean rate is 6 per 10 minutes. So for 30-minute period, it's going to be 6 3s are 18. Okay. So let's say this one we take it as variable. P follows Poisson distribution of 18. They say exactly 15 cars. We can find the probability, but we need to check whether we need it or not first. Okay, let's read the question further. Find the probability that exactly one car entered the safari park in the first 5 minutes of 30-minute period. Okay, you need to understand the question. This is 0 to 30. This is a 30-minute interval. There's a 5 here. Total of 15 cars entered, right? But they say the condition is one car entered here and the remaining 14 cars here. Exactly one car in the 5-minute interval. Okay, we can write this as a conditional probability. So this one, let's say I use a variable W. So it says the W is equal to 15. Probability of W is equal to 15. That's a condition. That's a condition. No, we don't put probability of W. W is equal to 15 is a condition. And then here, exactly one car in 5 minutes. One car in 5 minutes. They want us to find this probability. We know the formula for the conditional probability. P of A given B. That means P of one car in first 5 minutes intersection total of 15 cars divided by probability of total of 15 cars. So far so good, right? So we need to find W is equal to 15 here, and then what would be the intersection of these two? One car in 5 minutes and total of 15 cars. That means one car in 5 minutes, 14 cars in the remaining 25 minutes. This is 5 minutes. This is 25 minutes. So we need to find the probabilities and multiply them. So first I'm going to find P of W is equal to 15 first, which is e power minus lambda, lambda power x over x factorial. That's one probability. Let me calculate that first. E to the power minus lambda times lambda to the power 15x over x factorial, and store the value as a 0.0785 dot I store the value as a. Okay, now so this means one, we need to use some variables here. So I'm gonna use like f here and j here. Okay, f follows, it's 5 minutes actually. So 5 minutes, the lambda will be 3, right? Because the mean rate is 6 per 10 minutes. So we need to find P of f is equal to exactly 1. Okay, so here it's going to be P of f is equal to 1 times P of j is equal to 14 divided by 0.0785, etc. We need to calculate this. F is equal to 1. So e power minus lambda, lambda power 1 by 1 factorial, which is e to the power minus 3 times 3 power 1. 0.14, I'm going to store this value as b. 0.149, store it as b. And then for j, it's 25 minutes, right? So you need to write for 25 minutes, lambda is 6 per 10. So for 25 minutes, it's gonna be 6 times 25 over 10. That's 15. So j follows probability of Poisson distribution of 15. But we need to find P of j is equal to 14 now. You understand why we are finding 14? Because total of 15 cars. The first one arrived in the first 5 minutes already. So it's e power minus lambda, lambda power 14 by 14 factorial, and get all the values sub in here. So let's calculate this first. E to the power minus lambda times lambda to the power x over x factorial. Save this as C. 1024 ... Now we got all the three probabilities, so we need to write, therefore P is equal to this times this, 0.149 times 0.1024 divided by this, 0785. But in the calculator it's very easy. You can just write it as B times C over A. Get the final answer, 0.1947, 0.1947 ... which is 0.195. That's the answer. Part F now. Aston claims that the mean number of cars entering the safari park per 10-minute period is more than 6. He believes that it's more than lambda is more than 6. He selects a 15-minute period. So 6 per 10 minutes. So for 15-minute period, it's going to be 6, 15 divided by 10. Get 9. So we can write y follows Poisson distribution of 9. So he selects a 15-minute period in order to test whether there is evidence to support his claim. Find the critical region. So we need to find all the values that satisfy y is greater than or equal to y is less than the significant level. So I'm going to take the table values, all the table values that satisfy this condition. For lambda is equal to 9. Okay, lambda is 9 here. So first since it's greater than or equal to, always take 1 minus of this. Keep that number. So in the table you need to check where the value switches from less than 0.95 to greater than 0.95. So I have pasted the table values here. The 1 minus of this is 0.95. 0.95 is in between these two values, right? So when I take the value for 13, I should start writing it as y is greater than or equal to 14. So when I rearrange, I can use the value 13 here. 1 minus 0.9261. 0.0739 bigger than the significant level. And when I use the value for 14, I can start writing it as 15 actually. Which is, so when I rewrite, I can use the value 14. 1 minus 0.9585, 0.0415 is less than the significant level. So that's the first value. Therefore, the critical region is y is greater than or equal to 15. That's all. Just a 2 mark question. Question number 5. A bag contains large number of counters. 40% of the counters are numbered as 1. So P of number 1 counted with number 1 is 0.40. P of number 2 is 0.35. P of number 3 is 0.25, 25%. Okay. In a game, Alif draws 2 counters from the bag. His score is 4 times the number on the first counter. His score is 4 times the first counter minus 2 times the number on the second counter. Part A, show that Alif gets a score of 8 with probability this. When do you get this score 8? You are allowed to use these 3 numbers here and here. So which combination will give you 8? Take it this way. You put 1, 1, you won't get 8. 1, 2, you won't get 8. Definitely the first number should be 3. So you'll get 12. Minus 4, you get 8, right? So probability of score 8 is equal to probability of number 3 and number 2, right? Number 3, the probability is 0.25. Number 2 is 0.35. Calculate this. 0.25 times 0.35. 0.0875. That's what they want us to prove. That's all. Part B now. Find the sampling distribution of Alif's score. Okay. We need to find all the combinations first. You can take first one 1, the second one 1, or 1 2, or 1 3. Starting from 1. And we can use the same combinations starting from 2 and starting with number 3 also, right? We can use the same combinations starting with number 2. The first one can be the counter with number 2 or counter with number 3. We have taken all the combinations already, 9 combinations. Now, the score is basically 4 times the first number minus 2 times the second number, right? Okay. So here, when you sub in this one here, you're going to get 4 times 1 minus 2 times 1, you will get 2. Here 4 times 2, 8 minus 2, 6. 4 minus 4, you will get 0. 4 minus 6, you will get minus 2. 4 times 2, 8 minus 4, you will get 4 here. 8 minus 6, you will get 2, right? 3, 1. 12 minus 2, 10. Hope you understand what I'm doing. I'm subbing in all the values here. First value minus 4 times first value minus 2 times the second value. 4 3s are 12 minus 4. 4 3s are 12 minus 4. We got 8, right? Oh, that's what we calculated here, right? Okay. And then 3 3. 4 3s are 12 minus 6. So we'll get 6 here, right? Okay, did we use any variable here? No. Did they mention any variable? No. So you can write S is equal to Alif's score. Okay, and then write the possible combinations, and then what are the values S takes? Minus 2, 0, 2, 4, 6, 8, 10. You need to find the corresponding probabilities one by one now. P of S is equal to minus 2. We got minus 2 from here, right? So we need to take the probabilities. Okay, let me put the probabilities here for the reference. P of number 1, P of number 2, P of counter with number 3. The probabilities are this one, 0.4.35, 0.4.35, 0.25. So when minus 2, S is minus 2, the number is 1 and 3. So you need to take the probabilities 1 and 3. 0.4 times 0.25. When S is 0, there is only one combination, this one. So it's 1 and 2. 0.4 times 0.35. So probability of S is equal to 2. For 2 there are, okay, we are done with these two. For 2 there are two combinations, 1 1 2 3. So 1 1 plus 2 3, and then probability of S is equal to 4. There is only 1 2 2. That's 0.35 square. Probability of S is equal to 6. For 6 there are, okay, we are done with this and this. For 6 there are 2. 2 1, 2 1, which is 0.35 times 0.4 plus 3 3.25 square. We calculated 8 already in part A, so I'm going to calculate S is equal to 10 now. 8, we are done with 8 in part A. 10 is 3 1, so 0.25 times 0.4. Calculate all these probabilities and put it in a sampling distribution table. So let me calculate these values one by one. 0.4 times 0.25. That's 1 over 10. Either you keep all the values as fraction or all the values as decimal. 0.4 times 0.35. 7 over 50. This one. 0.4 square plus 0.35 times 0.25. 99 over 400. And then this. 0.35 squared. 49 over 400, and this 0.35 times 0.4 plus 0.25 square, 81 over 400, and this 0.25 times 0.4, which we calculated here already, 1 over 10. And for 8 you take the answer from part A. For 8 it's 3 and 2, so it's going to be 0.25 times 0.35, 7 over 80. We can write it here. P of S is equal to 8 is 7 over 80. We get the answer as a fraction. Now put all the values with the S values as a table. Okay, small s, P of capital S is equal to small s. The values are minus 2, 0, 2, 4, 6, 8, 10. This is 1 over 10, 7 over 18, 81 over 400, 49 over 400, 99 over 400, 7 over 50, 1 over 10. So this is the probability distribution table. But you need to do one more thing. As I always say, you need to make sure the sum of the probabilities is equal to 1. Always do that verification. So 1 over 10 plus 7 over 50 plus 99 over 400 plus 49 over 400 plus 81 over 400 plus 7 over 80 plus 1 over 10 Total is 1. That means all the values are correct. Next part, calculate ellipse expected score. Expected score E of S is sigma S times the probability. So you need to take the value of S from the table. So let me copy this whole table here. Okay, we have the table here. We need to take the value of S, multiply by the probability. Second one is 0, 2 times 99 over 400 plus 4 times 49 over 400, 6 times 81 over 400, 8 times 7 over 80, 10 times 1 over 10. So you will get the expected value. So it's going to be minus 2 over 10 plus 2 times 99 over 400 plus 4 times 49 over 400 plus 6 times 81 over 400 plus 7 eighths of 56 over 80 plus 1. 37 over 10 is the expected value. That's all. Question number 6. The continuous random variable has probability density function PDF given here. Sketch the probability density function. Okay, I'm gonna just take the function alone. You need to find the function values at -1, 1, 3 and 5. So f of -1 is, when you sub in -1 in the place of y, it's going to be 2 minus 1, 1. You will get 1 over 40. F of 1 is 3 over 14, right? Now you sub in 1, you sub in any value, there is no y here, so it's 3 over 40. And then 3, when you sub in 3, also 3 over 40. Here you try to sub in 3, you will get the same 3 over 40. Sub in 5, you will get 1 over 40. I'm gonna sketch the graph now. So draw the axis first. Always label them first. Y, f of y and origin. Okay, now listen to me carefully. From -1, let's say -1 here, the value of the function is 1 over 40. 1 over 40. Okay, you can just put a dotted line here and here. From 1 to 1, 3 over 14. Let's say 1 to 1. 1 is here. It goes up to 3 over 40. 3 over 40. And then the 3 over 14 continues till 1 to 1, 3. This is 3. This is 1. And then from 3 to 5, it's aligned with the negative slope. So it comes back to this point. There's 5 here. So you can extend this. This is the function PDF. That's all. The main important thing is not only the line, you need to mention these points actually. If you want, you can put a dot, this. That's all. Part B now. Given that E of y square is this, find this. The formula for variance of AX plus B, we have learned this in S1. It's A square, 2 square variance of y. You can leave -3, you can just neglect it. which is 4 e of y square minus e of y whole square. We know e of y square, but what's the value of e of y? Usually, how do we calculate e of y? Integral y times f of y dx. So basically, you need to take every function, multiply y, and integrate. That's gonna take very long time. This is when we are gonna use the graph. So pay attention, and I will tell you when to use this method. When you get a graph with lines like this, look for symmetry. Is this graph symmetric? If so, what is the line of symmetry? Because that's where the e of y lies. If you look at it, this distance from -1 to -1, 3 to 5 is 2, 2, right? And the middle point of 1 and 3 is 2. 2 is here. So let's say we draw a line here. Is this the line of symmetry for this graph? Yes, because this distance and this distance is also the same. And then look at this line. The line extends from -1 to 1 with the positive slope. That -1 to 1 is 2 units. 3 to 5 is also 2 units. So it's just a mirror image on both sides, right? So this graph is symmetrical about the middle line. So definitely e of y is equal to 2. This point is e of y. So you can just write by symmetry e of y is equal to 2. And then sub in here, therefore variance of 2y minus 3 is 4 times e of y square minus e of y whole square. Just calculate this. So 4 times 131 over 21 minus e of y whole square. 188 over 21. So whenever you get a PDF function, always look for symmetry. Using that symmetry, you can find e of y. Part C, the cumulative distribution function for this particular interval is this. So I'm going to put the f of x here, f of y. So for this interval, we need to integrate this function. So f of y is just a 2-mark question, so you can straight away integrate it. 1 over 14 y square by 2 plus 2y plus c. Since -1 is a lower limit, sub in this condition, f of -1 is 0. So 0 is 1 over 14, y square is 1 over 2 minus 2y plus 2y, 2 times -1 plus c. So you will get the value of c. That's 1 over 14 times 1 over 2 minus 2. That's minus 3 over 28 goes to the other side, positive 3 over 20. Therefore, f of y is equal to 1 over 4 y square over 2 plus 2y plus 3 over 28. If you take 1 over 14, sorry, this is 14 as a common factor, you will get this. So you can finally write, therefore f of y is, write it in the given format, 1 over 14 y square over 2 plus 2y plus 3 over 2. That's all. Part D is a 5-mark question. So I'm going to put a small f of x here. We calculated capital F of x for this interval already. Let's find capital F of x for the other two intervals. So f of x, sorry, did I put f of x here? It's f of y, yes. F of y is integral 3 over 14. So it's going to be 3x over 14 plus c. Okay. We have already calculated f of y is equal to 1 over 14 y square over 2 plus 2y plus 3 over 2 for this interval, right? So sub in y by 1 here to get the value. So f of 1 is 1 over 14 times 1 over 2 plus 2 plus 3 over 2. Plus 2 plus 3 over 2. You get 2 over 7. So that's the condition. F of 1 is 2 over 7. Sub in here to get C. So 2 over 7 is 3x over 14 plus C. Sorry, replace x by 1. So that gives us the C. 2 over 7 minus 3 over 14 is 1 over 14. Therefore, f of x is 3x plus 1 over 14. Why I change all the x? It's y, right? Now we need to integrate this and find the last one. That's why this question got 5 marks. Let's integrate the last one. So we will get f of y is 1 over 14 6y minus y square over 2 plus c. Okay. The last limit is 5. So replace the condition. F of 5 is 0. So 0 is 1 over 14 times 6y minus 5 square over 2 plus c. That gives us the value of c. 1 over 14 times 30 minus 25 over 2. Sorry, the condition is f of 5 is 1, right? Not 0. Because if you put the lower limit, that's 0. When you put the upper limit, it's 1, right? For cumulative. So 1 minus of 5 over 4 is minus 1 over 4. Therefore, f of x is 1 over 14 times 6y minus y square by 2 minus 1 over 4. Now we need to combine all the f of x and write the function now. So the first function is here, this one, 1 over 14 y square over 2, 1 over 14 y square over 2 plus 2y plus 3 over 2. And we have the second function here, 3y plus 1 over 14. 3y plus 1 over 14. And the third function, if you can just open the bracket, you'll get 6 over 14 is 3 over 7y minus 1 over 28 y square minus 1 over 4. You put 1 here, 0 here, and then write the limit same as f of x. Minus 1 to 1, 1 to 3, 3 to 5. Minus 1 to 1, 1 to 3, 3 to 5. You put it as y greater than 5, y is less than negative 1. Put a curly bracket. That's capital F of x. That's all. It's a 5-mark question. Part E now. Find the 30th percentile of y. That means f of y, it should be equal to 30th percentile 0.3. I'm going to copy the function here. We need to check in which interval the function takes 0.3. Let's sub in 1 here. So it's going to be 3 plus 1, 4 over 14. The value of the function is 0.28. So we need to check where that 0.3 lies in this interval or not. So when we sub in 3, that's going to be 3 times 3 plus 1, 10 over 40. 0.7, so 0.2 to 0.7 is here, so definitely 0.3 is also here, right? So we need to equate this to 0.3. So y, instead of y, write it as 30th percentile, right? So we use P30. So sub in the place of y. 3p plus 1 over 14 is 0.3. So 0.3 times 14 minus 1 divided by 3. 16 over 15. P30 is 16 over 15 is the answer. Leave it as it is. Now the next one is a conditional probability. Okay, I'm going to write it as P of y is less than or equal to 5 over 4. 5 over 4 is 1.25 given y is less than or equal to 3. So use the formula for conditional probability. P of A given B is A intersection B. The intersection of these two is same as P of y is less than or equal to 1.25, right? You can put it on a number line to find out the intersection. This is same as f of 1.25 divided by f of 3. So I'm going to put the function here again. So f of 1.25 lies in this interval, so you need to take this. For 3 also you need to take the same thing. So it's going to be, the denominator will be 3 times, replace y by 3. Here replace y by 1.25. That's the answer. 14 can be cancelled. So we will get 3 times 1.25 plus 1 divided by 10. 19 over 40 is the answer. That's all.